Hello, everybody. I'm sorry I've lost my voice a little bit talking to you all yesterday. And I'm quite jet lagged and I didn't get a lot of sleep. And this is my first time public speaking as an adult in front of a large audience, so forgive me if I stumble. So probably most of you know me as a student of Malcolm Bendel's. Maybe this is how many of you have discovered me. I am going to be talking a little bit about that in this presentation. I'm going to be mainly talking about the theory behind the technology, and it has far more application than just the technology. These are universal principles, and I believe that this is a new or a very old model of physics based on music and geometry. So I've titled my presentation, The Music of the Spheres, and I don't mean it as based on anyone's work in particular, but I will introduce it a little. It's more of an abstract, not an abstract, it's more of a highly harmonic concept that is self-evidential, and I believe I've made some progress on rediscovering and unifying these principles that have always been known by all cultures. So we'll get into that. So this is just a little slide from an app called Cosmic Watch. And it's what we're going to be talking about. This is the rhythmic and harmonic dance of the celestial bodies. And the idea of this is that from the macro to the micro, all things move in the same way. We live in a fractal reality. And all of these movements and pathways are determinable. And the ancients knew this. We know it now. It's just about putting all of these pieces back together. So a lot of people have spoken about the music of the spheres. Please ignore where it says Platonic solids after Pythagoras there. There's a few mistakes in my slideshow here, but Johannes Kepler, who came up with the laws of planetary motion, he was a mathematician and astronomer. He's probably who most people have heard the term the music of the spheres from. Pythagoras, he was certainly versed in these ideas and promoted them. Malcolm's stuff is very much based on these same ideas. And if we look back to ancient Bharat, India, we will find not called the music of the spheres, because it was a different language, but in the Gandharva Veda and in Jyotish, all of these principles are there in the same way, down to precise mathematical principles and numbers, which I will show you shortly. So just a few little definitions, because I know some people have come on the technology side rather than the cosmic side. The horizon, as you will see here. This is from the southern hemisphere, if you're wondering why north and south are on the wrong sides here. You all know it. The zenith, this peak in the sky, and this is just a lay of the land. It's to show you where we're going to go. The ecliptic is the pathway of the zodiac and the planets. And for those who don't know, everything just follows this line essentially within a spectrum of the ecliptic. So we can see the planets will rise in the east. Again, we've got north here because I'm in the southern hemisphere. You'll have south. But we can see the whole lot moves over time. It's very traceable, and of course, all modern astronomers are quite aware of this, and the ancient ones. So this brings us to the zodiac or radial cycle. We've essentially got two different ways, or two different motions that we track. And again, maybe some astronomers will disagree with me. I am self-taught, so I have missed a lot of normal ideas that may come up in education, and that's an advantage for me because it means I can discover things in a different way, but it's also a disadvantage because I may sometimes not be able to communicate in the same way as other people do. But essentially we have the zodiac or radial cycle, and this is our geocentric perspective. And if we look back to Jyotish, which is Vedic astrology, or any of these kind of forms of astrology, we see that all calculations are done from a geocentric, from the Earth-centric perspective. And, well, when I went to school, people just told me that that was because they thought that we were just the center of the universe, and they didn't know that the Earth rotated the sun and a number of other things. I mean, obviously that's very contestable, but the idea with Jyotish, with Vedic astrology, the reason why the ancient Indian astronomers came up with astronomy itself, or rediscovered these principles and tried to use them, was because they saw how these planetary cycles affect us on Earth. And that's, goes from agriculture to metalwork to, our own bodies. And I know a lot of people will think that's woo-woo. People like to disconnect astrology from astronomy, and that's reasonable because a lot of astrologers are bunk. However, we are full of conductive fluids. The moon moves the tides. The moon moves our bodies. It does alter our constitution. It alters everything. The planets affect us so much in ways that we don't understand that we are able to work it out. We are able to trace these things. And this is why we've got this radial cycle. This is the circle of the planets through the zodiac. We then have the heliocentric perspective, which is, of course, the Earth rotating the sun and all the other planets. So essentially it's a gyroscope. It's a giant gyroscope. We've got the moon rotating the Earth. We've got the Earth rotating the sun and all the other planets, and then we've got the sun rotating around another point. And again, many of you will be familiar with these ideas, but I have a diverse audience, so I just wanted to basically introduce these concepts first. No, there we go. They're going around really fast, obviously. 1 day, 2 days, yeah. You can see that. All right, so a little bit more on this. We've got these different lunar rhythms. And these 5 here are monthly rhythms. This is a daily rhythm. This is based on Brian Keats' work, who's a biodynamic calendar maker in Australia, and he taught me a lot about these cycles and phases before I started studying Malcolm's work. So we can see the moon, 2,160 mile diameter. And again, you'll go, no, it's not. If you look it up, you'll find it's slightly off, and that's fair enough. This is an architectural plan. Once you see how all of these numbers link together, I think you will agree with me that there is some intelligent harmonic design to this. And when these numbers go and interact with the world, they change a little bit. Just like when you go to build a building, you'll find that there are a few degrees difference or there's a small margin of error. And that's what these numbers are. You won't find them as exact, but you'll see what I mean by the end of this presentation. So we've got the daily cycle. The moon travels its own diameter every hour approximately. It travels 51,840 miles within 24 hours, and it travels 25,920 miles in 12 hours. So does anyone recognize that 25,920? Fantastic, yeah. You see where we're going to go with this. This is harmonics. So these monthly rhythms are mainly just for demonstration, just to show how everything is. It's got these multiple rhythms going on. We've got the phase cycle. Everyone should know, you can see it. We go around from the waxing moon and the waning moon. We've got the tropical rhythm, which occurs over a month as well, which is where the moon is moving between the tropics of Cancer and Capricorn. So when the sun is up, I always think about things in the southern hemisphere, of course, but when the moon is up your way, you actually get a miniature spring and summer. When it comes down our way, in the southern hemisphere, then you will get a mini winter and autumn. And so this is kind of like a miniature cycle of what the sun is doing, how it affects us. Next, the zodiac rhythm, which we discussed before. The apsidal rhythm, which is the expansion and contraction of these plasma bodies. Think of all these jellyfish-like layers surrounding the Earth, and you can kind of see how this works. It makes an elliptical orbit, which is why sometimes we'll find the moon is further, sometimes it's closer. And we've got the nodal cycle, which is where the moon and the sun meet on the same planes, what we see here, which that's the northern and the southern node, they call it, or Rahu and Ketu in the Sanskrit terms. So this is bringing this back. These are frequencies. It's all in very slow motion, but they are frequencies. So defining what frequency is, we've got its cycles per given unit of time. And again, perhaps debatable terms, but this is how I'm defining it here. It's work velocity over time. So we generally consider frequency in cycles per second, CPS, which is commonly referred to as hertz, which you may know it as, so 432 hertz or 440 hertz. It's the same concept here. All we're doing is we're replacing a second with a day here, and this is our sine wave. And we can see that the sine wave was developed based on these astrological cycles, which you will see happen on all scales of the fractal, not just with the planets. Now we're getting into the numbers. So this here, I've come to call the template based on my friend and fellow researcher Ed Nightingale's definition, based on the lambda sequence, which is simply doubling and tripling. We can see we've got 1, 2, 4, 8, 16, 32, 64, doubling down this column, 1, 3, 9, 27, 81, tripling across here, and then we have the product of these numbers in here. So 2 times 3 is 6, 9 times 2 is 18, etc. And that's all this is. And I think this is quite possibly the most important square you've ever seen, because it really does contain all the foundations of the reality which we live in. And I would go so far as to claim that this is the programming language of our universe. So if we look at the divisions of time for a start, these numbers may not look familiar unless you've been looking at my work or Malcolm's, or a number of people do talk about them. Like I said, Edward Nightingale. We'll go through a few more. Randall, of course, he's probably one of the first ones. But you can see here this 864, 72, ignore the zeros for now. 24, 12, 1, 12, 360, 864, 72, 24, 432. Think about these numbers. You can see them on here, and we can see how they fit together. These are octaves of each other, but we'll get into that in a moment. So I'm going to go through these fairly quickly because it doesn't matter if you remember them. I'm happy to give anyone this slideshow in full afterwards as well. I can make that available on my channel. But we'll just go through quickly and see if you can see the pattern. Greater divisions of time. We've got 1 solar year, 2160, 1 zodiac age, 3 zodiac ages, 6480, which is 1 platonic season. 4 platonic seasons is 12 zodiac ages, which equals 25,920 solar years, which is, of course, the great year. Biblical divisions of time. If we look at the 6 days of creation, and I actually think I may have got a typo on one of these numbers. I can't remember. Maybe it has an extra 0 or something, so don't judge me on that. I think it may be that 86,000. Yeah, I think it's 86,000, not 8,000. Anyway, we see again 144, 864, 518, 31,104 arc seconds. So these are all just conversions of the same thing. That's 6 days in hours, 6 days in minutes, 6 days in seconds, 6 days in arc seconds, which is a further division of seconds. And obviously links to the circle and these measurements here. So it's curious that we find that in the Bible, because if we go to the Vedas, then we find those arc seconds in Earth years. 311 trillion and 40 billion Earth years is said to be the lifetime of Brahma, who is said to be essentially the creator god of the Vedic tradition. So a kind of secondary god that created the universe. 360 days is 1 year of Brahma. 24,000 Deva years, which is Daiva Chakra, I think. 8,640 million Earth years. So you're starting to see these numbers recur again and again. And they are there specifically in these scriptures. Both, the Bible is more, you have to decrypt it a little more, but it is in there. You find those 6 days, you find plenty more stuff than that. It's all there in the Indian stuff as well, very explicitly. And I read these numbers a long time ago, and I was like, why are they giving us such, who cares about 4,320 years? Why does that matter? How does that make sense? They were giving us a key, because this helps us verify that everything happens in the same pattern, on all scales of the fractal. So if we look at the yugas, which probably most people know most commonly, Kali Yuga is, which we believe we are currently in, debatably, 432,000 Earth years. We see it's double that, 864, is Dwapara Yuga. Treta Yuga, 1,296,000 Earth years, and you're beginning to see the pattern. Other ancient calendars, we've got 36,000 years for the Egyptian Kings list. I got that one from Ed Nightingale, a few of these. 6,000 years on the Hebrew calendar, 144,000 days equals 1 Baktun in the Mayan world ages. 432,000 years, reign of the Sumerian god kings, credit Randall Carlson or wherever he got it from. 3,600 years, Saros cycle and ancient Chaldeans. And then we've got traditional systems. So we've just skipped. We were talking about time, right? Now we're on measurement. And you probably know these even more than you would the time, because they're a little more in our face. You've still got the imperial measurement system here, right? People use that in the US. We don't have it. We went to metric, and it was a bad idea, guys. I thought it was a good idea. It's not. So spiritual significance. Yeah, I hope you guys love that one. Spiritual significance. 9 inches is a span, and that's said to be based on God's hand span, which he meted out creation in the Bible. Interestingly enough, in the Srimad Bhagavatam, 2nd canto, 9 inches exactly is said to be the span of Krishna's universal form, which is a metric for creation on a fractal scale. 144,000 faithful followers in the book of Revelation, 144 square cubits in the sacred city of Jerusalem, 108 beads on the Japa Mala, and I'm sure you guys can probably name many other things that have to do with this 108 number. It's a very, very sacred number, and we'll find out more about it shortly. Imperial measurement system. And so I've done a fair bit of research on this because I started to see this pattern, and I was like, surely people have noticed this. And I was looking it up, and people were variously saying that we just arbitrarily came up with our measurement systems, or that they were based on natural objects, like your finger, like a barley corn, 3 barley corns in an inch, for example. That's true, but that's because these numbers are the programming language of our reality. They can both be true. 12 inches in a foot, 18 inches in a cubit, 36 inches in a yard, 2 cubits in a yard, 3 feet in a yard. It's all there. The Welsh measurement system, and there's a very interesting story behind the Welsh measurement system that I think everyone should look up. I think he was called Dwifnell the Bold and Silent. Look it up. I'll leave it there. Great Pyramid, and this is again from Randall, is a 1 to 432,000 scale model of the Earth. It also has a 51.84 degree slope angle. We've seen that 5184, if you can remember it, very significant number before for time, the number for time itself, in fact. Essentially, numbers are real and alive, like Marco Rodin said 40 years ago, and Malcolm's been telling us now. We've looked at things linearly. We read a number left to right. And this has been coming up from other people a bit lately, and I confirm that they're right. They're right. We are missing about 80% of our maths. We are not using numbers properly. And that's not to say that we can't do fantastic things with numbers the way we use them. Like, I am aware that we are great engineers. We have worked out a lot of stuff. But it's like we're doing that with the 20%. This is analog computing. This is the difference. We have the British apothecaries' weights as well. So we've gone to measurement to weights now. And you'll see once again, 1, 12, 96, 288, 5, 7, 6. So you can see them all highlighted there. I don't need to go through them all. These systems continue to go back a long way, and I've only listed a few here. There are so many more, and you will find these numbers again and again and again and again. If you print off this little square here and start looking for these things, you will find thousands of more examples that I haven't given. We've got traditional systems of weight, further ones here. Traditional systems of volume. So we've got 1 pint, 16 fluid ounces, and so on. UK Imperial, and again, many other examples of this. These are not the only ones. I just thought they might be relevant to everyone and demonstrate the point well. Measurement of the celestial bodies. So let's start up the top. Ignore the estimated diameters for the moment. We've got 1,080 miles is the moon's radius. 2,160 miles is the moon's diameter. 432,000 miles, sun's radius. 864,000 miles, sun's diameter. Then we've got 7,920 miles is the Earth's diameter. That's not on there, right? Curious. But if we look at 1728, I have a video called The Laws of Sanskrit Mathematics. We probably should have called it The Laws of Vedic Mathematics. Also The Laws of Vortex-Based Mathematics, because they are synonymous, where I explain this. But we can do a lot more with these numbers than reading them left to right. They can implode, they can explode. We can take each digit and find out its meaning. We can shuffle them and find out its meaning. There's a lot of equations in that video that I would encourage everyone to go and see if you're interested in this. The sun and the moon's average distance from Earth, 108 times their respective diameters in miles. And of course, we see Tesla's magic, 396 miles is the Earth's radius. It's that simple. I thought about doing a little video actually of just, what's the big mystery? It's the Earth's radius. And once again, if you're an astronomer and you've studied this from an academic perspective, you may find these numbers very disagreeable. Look at how they reference each other. Everything, once it comes in play into this world, it is subject to the feedback mechanism of other things. So for example, we know that all ancient cultures seem to think that there was 360 days in a year, or they mentioned the 5 as unlucky days. Why is that? I think it's because of the impact. I think that when you look at these spheres spinning around each other, someone asked me yesterday, why doesn't the Earth get sucked into the sun? Why does it stay there? Well, I think it stays there because of this. This is all vortexes, and this is the language which we can map it with. The other planets, estimated diameters, and I've just estimated these myself. Someone feel free to go and do it yourself based on these numbers. Like I say, you're going to find that the sun's radius or the sun's diameter is said to be slightly more than this, or I think it's 865,000 miles or something. The Earth's being knocked slightly off. We're slowly going back, and we will. You're never going to find these numbers exactly, or very rarely will you, but you are going to see that this is the architectural plan. The magnitude of different planets as well, which is just funny. You keep finding more and more things that just fit in. But again, Ed Nightingale, here he is. See this man with the white hair here? Everyone go and chat to this guy afterwards. We're going to talk about that a little bit more in a moment, but magnitude of Sirius, negative 1.44. You just can't make this shit up, can you? So here's the crux of it, how it all ties together. This is a musical scale. It's the music of the spheres. I believe this was originally how Pythagoras came up with our Western musical scale based on, again, the Vedic music scale, which already had a 12-note scale as well as a 24-note scale. Essentially, all we've got here, each column is an octave. So an octave just means double the frequency. For example, 432. We've tuned all our instruments now to 440 hertz. That was a rather arbitrary decision made, I think about 100 years ago, maybe. We probably should tune it to 432 because you can see that it makes everything a lot easier and our harmonics start to work. So 432, double that is 864. So that'll be the same note. They'll both be A. They'll both be A, just one tone higher. You know, if we've got it. Anyone got perfect pitch in the room? No. That's a rare one. Fair enough. Well, let's pretend this is A. There you go. Sorry, I lost my voice, but that's an octave higher. It's that simple. Oh, sorry, I thought I had another slide there. Nope, there it is. All right. On the other hand, in the other direction, on the horizontal axis, we have the perfect fifths. So 256 this is hertz, by the way, because we're just skipping between, you can use these numbers for anything, so I've stopped labeling them. But this is hertz, or cycles per second. 256 cycles per second is middle C on the piano. So when you hear that middle C, that's that. A perfect fifth, up from that, is 384 hertz. Perfect fifth up from that is 576, and so on. We can actually build a musical scale quite easily by going 256th and then going up a perfect fifth. I use a chessboard to demonstrate this sometimes, and I call that the bishop move. And then we've got our knight move, a perfect fourth up to down to 288 hertz, 432 hertz, 324, 486. We're building a musical scale. So if you don't know what this is, we can build a full chromatic scale, which just means every note. You know, if you're starting on C, and then we've got 12 notes, you'll go C, C sharp, D, and go up that. But this is in the order of perfect fifths. Nope. There we go. So we get to this, this line of the 1, 3, 9, 27 here, because we need to build the rest of our scale, and I only got half the notes in. And we can do a halving sequence. So this is just halving and tripling. So we've got 0.5, 1.5, 4.5. If we go up this way, we've got 0.25, 0.125. So we're just halving now. And we find that we get these decimal places, but we do get the rest of our scale. And there's some very interesting things to observe between here and here. If you look carefully, you'll see that pretty much every number here is mirrored, just with a few extra decimal places. It's bizarre. It's really, you could not make this stuff up. You can also see that these numbers are compounds, and it's not maybe that easy to see because I cut it off here. We can continue this infinitely down and infinitely across, and we can create a microtonal scale with more than 12 notes if we wish. It will start filling in the gaps rather than just expanding further. But yeah, we can see essentially these numbers are all made up of other numbers, you know, so where's a good example? It's nice and easy to read. Here we go, 4808. This is just one example, but it's 48 here and 8. I'll let you guys look around this for yourself. There's plenty of time to explore it, but you will find all of these numbers are compounds built of each other. The rule changes a little bit when you introduce fives, but I'm not going to bother trying to explain that right now. So then we've got the zeros, because I told you to ignore the zeros, and that's just to start to get a little scope of these numbers. But I figured out that when we increase the amplitude or the magnitude, I'm not sure what the appropriate term to use is in these terms, but we shift the musical scale a few places. So for example, here instead of 1 in the corner, I've started with 0.1. And so we can see that our C has now moved 1, 2, 3, 4 places to the right, and it's shifted our musical scale. So now we can see 3.6 hertz is going to be A sharp, and of course that's below the normal range of human hearing, but that is what's interesting about this, and we will get into that in a little bit more. We can also add a 0, so now our 1's become a 10, and we've shifted the scale the other way. The zeros don't matter, they're just amplitude or magnitude. Further resources on these numbers. Malcolm Bendel, of course, his plasmoid unification model. uses these. Marco Rodin, who was the discoverer of vortex-space mass, and he recovered that from the Baha'i scriptures. So just throwing in another scripture there that also has these exact numbers, all based on the number 9, that handspan of God and the universal form of Krishna. And I'd love to hear from anyone else if you know of other spiritual traditions where you find these same numbers. Randall Carlson, of course, he's got a fantastic video on After School, which goes through a lot of these numbers, which some of you may have seen, in which case you will understand these concepts. Edward Nightingale, in the back there, he's going to be here all weekend, and I really encourage everyone to go and talk to Ed about his work, because I solidified a lot of these concepts and understood them through Ed's work. And I think very few people may know of him at the moment, but he's been around for about 20 years, and it's some of the most fantastic stuff out there. Walter Russell, who I've actually only really started studying myself, even though he's a major inspiration and credit for Malcolm's work, built on the top of it. But his model of the elements, we find this same thing. This is an octave sequence. Everything's separated in the same way. You can map the same numbers onto this. It's there. He knew. Fellow I met recently, Don Odish. I'm sorry, I don't know how to pronounce that last name. But he's mapped all of these numbers even further. You can find the circumferences and the movements of the planets, and you'll find all of the same numbers there. I brought along a document from him if anyone would like to see it, or I'll upload it as well and share that. Jamie Buturf, you can find him. He was kind of the original guy who started fighting to bring back 432, and he got in a lot of trouble for it. I think he got in quite some argument. It's it's a passionate topic once you get into it. But he actually was probably the first person that I saw these numbers through. Bruce Cathy, I'm sure many of you will know of him. He mapped the ley lines of the Earth, and he did all of this based on UFO phenomena. He was a pilot. You'll find these numbers prolifically through all of his books. And Pappas, what was his name? I think his real name was Gerald Encalce, but this was a book called Tarot of the Bohemians from early 1900s, late 1800s. The patterns are in there, and this is maybe even one of the first places that I learned them. And I highly recommend this book. Essentially, the fortune-telling thing, it works maybe, but those cards are about numbers. There are hidden mathematical principles in this deck. There are many, many other people that talk about these numbers, but these are just a few important ones. And like I say, obviously Randall's here, Malcolm's here today, Ed's here today, so make sure you reach out to those guys, talk about this stuff as well. Music of the spheres. Space and time are harmonic and fractal, and so are our systems for measurement and division, as above, so below. The great year of our solar system is 25,920 years, and the melting point of protium, what we commonly know as hydrogen, which is a group, not an element, is negative 259.2 degrees. It's pretty telling, isn't it? And there's way more to this, As we keep finding smaller particle designations, we can keep going deeper and deeper, but we're going to be able to go forever. Maybe we'll even find us on the other side of it. I'm not sure if we went down far enough. So this brings us to the frequency spectrum, and I hope this will kind of clarify what I've been talking about for those who may not be getting it all. But we've explored the musical scale already, so let's start with that. We can see that that's all, well, at least the notes that we can hear are within the range of audible human hearing, which is around 20 to 20,000 hertz. Some people can hear a little more or a little less. We all have different things. Then we've got, well, I should say first, so that's one of our senses, right? We hear a certain range of frequencies, but everything is a frequency. It's like our senses are bandpass filters. If you're a musician, you can, they're limited, the frequencies we see. For example, we don't hear color, we see it, because we have a sense that's designed to pick up only those frequencies. We hear things in the audible spectrum because our ears are designed to pick up those frequencies. So if we look up a little further, here's our visible light spectrum, 400 to 790 terahertz. Terahertz is 1,000 gigahertz. Gigahertz is 1,000 hertz. So we're getting up, it's going pretty fast. But essentially, easy way to think about this, if you don't know what frequency is, people say it's vibration usually. I don't think this is actually correct. Ken Wheeler says oscillation is the right term. But we can think of it as vibration. So it's just how fast is something vibrating. So if it's vibrating at 20,000 hertz, it means it's vibrating 20,000 times a second. That's as simple as this is. If we look down right at the beginning here, we have the human brainwave spectrum. If you've ever had an EEG scan, and you can actually do this all over your body, they've got different sensors that essentially do the same thing. They pick up the low current electrical signals being emitted by the human body because we are electrical in nature and these things can be tracked. So we can actually find out, many of you may have done meditation practices, or you can get headbands that track this and tell you where you are these days. We're usually sitting in either, probably everyone's mostly in beta these days, which is conscious awareness, a very focused state. That's where you are when you're at work. Alpha, you can see it's a little lower, so we went from 14 to 30 hertz to 8 to 13 hertz. This is more of a resting state when we're in a relaxed state. Many people are in the flow state, when they're in this alpha. We go down to theta, 5 to 8 hertz. This is very meditative, hypnotic, when you're on the way to sleep. Delta, deep sleep, 0 to 4 hertz. Interestingly, if you go below that, then we get REM sleep and the dream world, and then you'll go back into beta, which is quite funny. What does that mean? Then we've got gamma, 30 plus hertz, and traditional EEG scans will only go up to 100 hertz, but recent work in neurosciences over the last decade has shown that we can, the human mind can go well over 2,000 hertz, I think. They've been tracking maybe even far greater than that, a huge release of energy. This is generally when people get in a meditative state and go below the delta state. You can essentially activate the pineal gland, let's not mince words, and you will have an experience. Then we've got all the rest of the frequency spectrum. I'm not going to go through all of these, but obviously we've got the radio spectrum here. We've got the nuclear, sorry. I'm Australian, we're not great with this stuff. It's worth mentioning. We've got the nuclear kind of spectrum here, and I mean, we've got UV light at this end of the visible light spectrum. And outside of the visible light spectrum as well. But we go all the way up to X-rays, gamma rays, cosmic rays, and they're just going really fast, too fast for us. That's why they mess with us. All right, this is just a little example that I got from a book some of you may know called The Kybalion. And it's a surprisingly good example of what I'm talking about. So I'm just going to read this little text and we're going to go through this slide here. Scientists have offered the illustration of a rapidly moving wheel, top, or cylinder to show the effects of increasing rates of vibration. The illustration supposes a wheel, top, or revolving cylinder running at a low rate of speed. We'll call this revolving thing the object in following out the illustration. Let us suppose the object moving slowly. It may be seen readily, but no sound of its movement reaches the ear. The speed is gradually increased. In a few moments, its movement becomes so rapid that a deep growl or a low note may be heard. Then as the rate is increased, the note rises one in the musical scale. Then the motion still being further increased, the next highest note is distinguished. Then one after another, all the notes of the musical scale appear, rising higher and higher as the motion is increased. Finally, when the motions have reached a certain rate, the final note perceptible to the human ears is reached, and the shrill, piercing shriek dies away, and silence follows. No sound is heard from the revolving object. the rate of motion being so high that the human ear cannot register the vibrations. Then comes the perception of rising degrees of heat. Then after quite a time, the eye catches a glimpse of the object becoming a dull, dark, reddish color. As the rate increases, the red becomes brighter, and then as the speed is increased, the red melts into an orange. I think that might have been my next slide, let's see. Yep. Then the orange melts into a yellow, then follow successively the shades of green, blue, indigo, and finally violet as the rate of speed increases. Then the violet shades away and all color disappears, the human eye not being able to register them. But there are invisible rays emanating from the revolving object, the rays that are used in photographing and other subtle rays of light. Then begin to manifest the peculiar rays known as the X-rays, etc., as the constitution of the object changes. Electricity and magnetism are emitted when the appropriate rate of vibration is attained. When the object reaches a certain rate of vibration, its molecules disintegrate and revolve around themselves into the original elements or atoms. Then the atoms, following the principle of vibration, are separated into the countless corpuscles of which they are composed. And finally, even the corpuscles disappear, and the object may be said to be composed of the ethereal substance. Science does not dare to follow the illustration further, but the Hermeticists teach that if the vibrations be continually increased, the object would mount up the successive states of the manifestation and would in turn manifest into the various mental stages and then on spiritward until it would finally re-enter the all, which is absolute spirit. The object, however, would have ceased to be an object long before the stage of ethereal substance was reached. But otherwise, the illustration is correct insomuch as it shows the effect of constantly increased rates and modes of vibration. It must be remembered in the above illustration that as the stages which the object throws off vibrations of light, heat, etc., it is not actually resolved into those forms of energy, which are much higher in the scale, but simply that it reaches a degree of vibration in which those forms of energy are liberated in a degree from the confining influences of its molecules, atoms, and corpuscles, as the case may be. All right, we'll leave it there. You can read that book yourself if you like, but I think it's a good demonstration of these principles. Moving on. This is the Vesica Pisces, a fractal Vesica Pisces going on, and I'm currently writing a book on this where I explain harmonics through the Vesica Pisces, and so I've briefly just given a little example. Here, we can see that this full circle could be considered the fundamental frequency. So imagine this as a string, and these as cavities. We find that the division here gives us 2/3 of the string, a perfect fifth. In the center, these two circles give us an octave each. If we were dividing our string this way, would work the same for wavelength, I guess. And a perfect fifth 2 octaves above, we get this. There's a lot more to find in this. I'm not going to go into it right now, but let's just briefly talk about harmonics. Essentially, one note is not made of one note. When we pluck a string and we hear, let's say that this is tuned to A 432. Let's say it's tuned to D72 because I've used that as an example. If this is tuned to D72 and we pluck this string, we hear a D. It's made up of many notes. There is a fractal harmony of notes, and this is well known. This is not new woo-woo stuff. This is just standard music theory. I believe it's a model of physics. So if we've got the first harmonic will be our D72. That's our full string. If we go down, our second harmonic is just 2 times 72. So it'll be an octave up, D144. This is also 72 plus 72. I know that's the same thing as 1 times 72, but it's important to see how these things are constructed. We look at the third harmonic, 72 plus 144, and this is also 3 times the fundamental. Fourth harmonic, 288. Fifth harmonic, this one's interesting. I believe I actually did write it F sharp. Yeah, okay. Sorry, I can't see it very well from there. 288 plus 72. This 360 here, this is a very interesting number. And this fifth harmonic, it actually has another whole key to mathematics that I think everyone's missed, frankly. We'll see. It will be interesting to see if anyone knows it when I come out with my book. There's the fifth harmonic, the seventh harmonic as well in the center. We'll see 504. And if you remember correctly, we saw 54 or 540 or 5.4 on the template. We did not see 504. And there is another key to numbers in here. And this is undeniable stuff. I wish I had been able to publish the book in time to show you guys this. But there are keys encoded in the Vesica Pisces, including the great year, the 51.84. All of these numbers are directly encoded in the geometry, and I will talk about that later. But for now, a note is made up of many notes, just like everything is made up of many things. Moving on to geometry, I just want to talk about these numbers for a moment more. Three-sided shape, 60 degrees times 3, 180. Four-sided shape, 90, 360. 5, 108, 540, 120, 720, 1080, 135, that's a little bit of an abnormality. 126, 144, we get shuffled numbers sometimes, 216, 126, 144, 360. Once again, so we've got what? Measurement, time, the celestial bodies, the shapes. It's getting weird, isn't it? 3D shapes, tetrahedron. 720. Of course they're going to be the same because we know the 2D shapes were there. We add up the 720 of the tetrahedron, the 1440 of the octahedron, the cube 2160, the icosahedron 3600, and the total sum of all their internal angles is what? Diameter of the Earth. How about that? Then if you add that to the dodecahedron, you'll get 14400. There's our 144 number for light. We know it. So that's all for the numbers. We'll leave that there. I think it's pretty interesting. I think it's undeniably self-evident that everyone knew about these numbers, that all of our systems for time and measurement, at least the good ones that match nature, were built on these principles. So moving on, I want to talk about power generation and plasmoids, because that's where we're going. And again, if you came to see the technology and you're like, why is he rambling on about ancient history? You'll see how it applies. You'll see. So this is a Tesla coil circuit. Everyone know what a Tesla coil is? Yeah, it's essentially, if you saw Nikola Tesla standing there and he had the toroid on top of the giant coil and the lightning's coming out at him, that's a Tesla coil. It's a very simple circuit, which is kind of the basis for our entire modern architecture of the AC electrical grid. So AC is alternating current, electrical current. It's moving at a specific frequency, cycles per second or hertz, whereas DC, direct current, what you get from a battery, doesn't have a timing yet, or it does, but it's on a very fractal scale, and we can't really identify it. Essentially, what we've got here is just a circuit diagram. We're going to come back to this and explain how power is generated, but this is essentially, it's a power input. Imagine that as your wall plug right now, and then I'm going to go through and explain what these parts are. I'm going to do it through the lens of time and frequency, so usually you'll hear voltage and current and working out capacitance and inductance and resistance, and I'm not going to talk about any of that. It is all useful, but this is another way of thinking about things. And again, I don't think this is commonly known or in the electrical engineering textbooks. Correct me if I'm wrong. I'll be happy if it is. So we've got here our AC power input. We've got here our Tesla coil with a little toroid on top, and that's the bit that's the lightning's coming out of. So this all happens through sympathetic resonance. The primary coil of the high voltage transformer is excited by the power supply. It resonates at its natural resonant frequency. The secondary coil, tuned to the same fundamental frequency or a harmonic of the fundamental frequency, resonates in sympathy. So all as this means, this coil here, these coils, we know coils. I forget that maybe people who aren't familiar with electrical stuff may not know, but coils are what have built our entire electrical grid. This is why we can distribute power. This is why we can manipulate power in certain ways, is coils. It's just a coil of wire. That's it. They're like musical instruments. A string, if we stretched out a copper wire and we plucked it, it would have a frequency. Or if we put a signal generator or some kind of electrical stimulation on that string, it would vibrate, and it would vibrate at its natural resonance, just like when we tune a guitar string. You know, we tune it to E, you're going to get the E, you know, when you pluck it. It would depend on the tension and everything else, but once you've got that, you have your reference point, you have your E. So these coils are the same, they're tuned to a note. All we're doing here is we're exciting this first coil, and when that first coil starts to vibrate, starts to resonate, the second coil, if it's tuned to the same frequency, will do the same thing. And that's a transformer, essentially. They're wrapped around an iron core, which kind of messes with the tuning, and I don't think it's a very good idea, but there is a reason for that. They do that for a reason. So this is exactly how the coils here are going to work as well, and we'll get to that in a moment. A capacitor is the other important component of an electrical system. It charges and discharges high voltage at a certain frequency, timed pulsing, just like a tuned quartz crystal in a wristwatch. So you're seeing that tick, 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 because a crystal has a certain capacitance. So when it's stimulated with an electrical signal, it'll pulse. And so if we tune it to the right frequency, that's how we got quartz watches. And there are other ways to do that. We had mechanical watches before that, but it's just a good example, I think. That's what a capacitor is. You're feeding it some kind of source, it's pulsing. The capacitor should be tuned to the timing of the spark gap, which is this fellow here. Essentially, a spark gap, it could be as simple as 2 bits of metal placed just a little way apart. When enough charge builds up in one side, just to put it simply, the spark gap arcs. When there's not enough charge, the circuit is open, and therefore electricity can't flow. You need a closed circuit for things to move. But again, this is the part that I don't think is commonly known, but we need to tune the spark gap and the capacitor to the same frequency, ideally, because this all works on time. And the reason why I'm making this point, because if you don't know anything about Tesla coils electricity, you probably don't care, and you don't understand the relevance of this. Where I'm trying to come from is that it isn't taught this way. We're not taught in terms of frequency or time that it works this way. The capacitor should be tuned to the spark gap. If they work in time, they will pulse and charge in time, and time is the integral element here. We don't have to do it like that. They work it out a completely different way usually, but you won't get such a good result. I checked this stuff on ChatGPT, and it even agreed with me after a while. I had to kind of trick it because it wasn't happy about me talking about coils. It was like, no, it doesn't work like that. Go read the book. I asked it about tuning forks, gave me all the answers, and then I said, does that work with coils? And it couldn't say no at that point. You can play chess with that damn thing. So it works like that. All of this is done to stimulate this coil. This is the real primary coil here. And all of that is done to make this coil here resonate, which gives us a very, very low current, high voltage discharge through the top load. It's all timing. It's all frequency. I say this because there's so many terms and so many different ways and so many calculations and pieces of software to work this stuff out. But I don't think Tesla understood it in that way. I think he understood it in this way. This is why he was able to work quickly. All of this is to rapidly form and collapse the magnetodielectric or electromagnetic field in the primary coil, which causes the coil to resonate at its natural resonant frequency. So I'm just using 432 kilohertz, which is 432,000 hertz as my sample here, just to show that we're just tuning it all to the same thing. And if we get the circuit moving like an organic being, because it is, we're creating an arch form here to structure life. Electricity is more than we think it is. Then we'll get this coil to resonate. Essentially, there's the lightning coming out of it. Okay, we're going to come back to that one in a second. This is how our whole electrical grid works. So, we hear, I don't know if it's 50 or 60 hertz here in the US, but all those big power lines, they're all just resonating at this frequency, all of them. And all as they're doing to keep that whole grid flowing is they have to keep it at resonance. And so if you go and turn on your power switch, it's just added a bit more to that circuit. Your tuning is going to go down, I think, down. They need to just bring it back up. It all works through timing and resonance. I believe that we are thinking about these things in the wrong way. Harmonics as well. This is another one that I played chess with ChatGPT on, and I discovered that we don't use the harmonics. I was actually really kind of surprised at this because, like I said, I don't really study things from the conventional perspective, so I often find out later that I found out stuff that no one seems to be aware of. Usually we've just got a primary and a secondary coil. That'll be, say, 432,000 hertz. That'll be 432,000 hertz. The circuitry may make some adjustment for that, but we account for that. We're wasting the harmonics, though, because once again, it's not like a hose or the harmonics of the note. We've got that 432. We're picking that up. We've got the fundamental frequency, and then this coil's resonating at the same rate as that, but all those harmonics we explored are being wasted. They may get picked up by this coil. They may not. We could put more coils, essentially, or we could design one coil that has fractal elements to it, and we would be able to harvest those harmonics. I checked again on ChatGPT with that, and it very reluctantly, it refused to say that I broke the laws of conservation of energy, but it did say that theoretically that would produce more power out than in. So I don't know. It's just a bot, but I think I'm right. Here we're going back to the power supply. So I'm just going to talk briefly about a motor and a generator and how they go together. How am I doing for 3 minutes left? All right, let's go quick. We're going to end with this. Through the lens of time and frequency, the turbine spins. So this could be wind, could be hydro, could be a combustion engine blowing up and the pistons turning this, whatever. The turbine spins, and this causes the attached rotor with magnets on it to spin. The magnets pass by these tuned stator coils, causing the coils' magnetodielectric fields to form and collapse. So the coils resonate. We're doing the same thing here. It's all based on timing. We spin the magnets. A coil's just an electromagnet. And a magnet is just a kind of permanent coil, really. It's just kind of constantly resonating. I'm not going to try and explain a magnet. Go check out Ken Wheeler if you're interested in that. They spin past these coils, power's generated, done. Inductive motor, it's just the reverse. If you've got like a brushless drill, for example, the coils will activate in sequence. This turns the magnets, that turns the rotor. AC power is all a matter of timing, frequency, resonance. Nikola Tesla's genius. Who regulates this? Plasmoids. Come and talk to me about that later. I'm all done, guys. Wait for Bob Greenyard.